Hello everyone, today we'll talk about the solution to the problem divide players into teams of equal skill. So we start by reading the statement. We see that we want to group the values into pairs such that the sum within each pair is the same, and in that case we want to calculate the products within every pair, sum them together and return them. Now that seems pretty weird, because what if there are many ways of dividing players into teams? Should we return the biggest possible product, the smallest possible product, maybe any product? Typically in competitive programming problems, you will have this statement at the end that if there are many ways of dividing players into teams, then return the product of any correct division. But it's not given here, so either the problem is not well stated, or it's not necessary to specify which division we want, which is exactly the case when there is only one division, or at least only one value for the product. And indeed, this is the case in this problem. So that is one way of arriving at that observation, that teams are essentially predefined. Another way is to notice that the sum of skills of all the players is given at the beginning. That's just the sum of skills. So if we take that sum of skills and divide it by the number of teams, so divided by n over 2, we get exactly the total skill of every team. And so that means that for every person, we know their skill, so we know exactly what the skill of the other person should be on their team. And in particular, and that's another way, and my preferred way of looking at problems like this, is that, okay, we have to get people into teams, and so everybody should be in a single team. So the best person should be in some team, and the worst person should also be in some maybe other team. So is it possible for them to be in different teams? Assume for simplicity that every person has unique skill. Well, it's not possible. That's because if we take the best person and give him somebody that's better than the worst person, then their sum of skills will be bigger than if we take the best person and the worst person. And that is the biggest possible skill that the team for the weakest person might have, right? So if we have the biggest, if we have the smallest, and somebody who's in the middle, we cannot get the big with the middle, because somebody will be in a team with the smallest, and that somebody can be at most as big as the biggest player. Likewise, of course, from the other side. So we see that we take the best player with the worst player. And of course, after doing that, we have one team ready, and we can look at the remaining players and do the same thing. And this is the solution that we'll implement by sorting the list of skills at the beginning. The value for a single team should be the skill of the first player, the worst, plus the skill of the best player. We remember the final result, which is again the sum of products of skills within each team. We go through the first half of the array, take the skill of the first person, of the second person. We verify that it's equal to our target. If at any point if it's not equal, we just return -1. Otherwise, we take that product of their skills, add it to the result, and we return the result at the end. So this is an n log n solution because we do sorting. It should also be possible to do it in linear time by using a hash map, because, again, if we know the value for every team, which can be received by just taking the sum, dividing it by n over 2, we can just go through all the players and see if we have at least one remaining player of the appropriate skill to create the correct team with the player that we're looking at.